This section's main focus is on binomial distributions. So the first thing we're going to talk about is binomial probabilities. And with a binomial probability, you only have two possible outcomes, thus the beginning or prefix of bi. And those two possible outcomes are either it being a success or a failure. So for example, if you wanted to draw a red card, you would either draw a red card or you wouldn't. So it'd either succeed or fail. So there's two possible outcomes. So the probability of getting a success is the same for each trial. So it doesn't change. So it stays the same. And if you're trying to find the probability of a failure, you can use the whole idea of complement. It's 1 minus 1 being 100% or all of the outcomes, minus the probability of a success. So in this example, if I have the probability of succeeding being 2/3, probability of a success, then the probability of getting a failure is 1 minus 2/3, which would end up being a 1/3 chance. Now notice both of these two guys, they add up to all the possibilities, they add up to a 1. So you either succeed or you fail. So there's a formula that you're going to be using to calculate the number of successes for a binomial experiment or binomial probabilities. And here's what it is. So the probability of getting k successes out of a certain number of trials is equal to this formula, which looks pretty intimidating. So here's what everything represents, and I'll kind of go through what the formula is. So first, n is the number of trials. So for example, if you're drawing something 10 times, then n would be 10. That's the number of trials that you have. K is the number of successes. So for example, you're drawing 10 times and you want exactly 5 successes, K would be 5. So P is the probability of a success. So if it's like beans in a bag and you had 2/3 of them being red and a third not red, you'd have a 2/3 of a chance of drawing a red, which would be a success. So that would be the probability of success. And 1 minus P is equal to the probability of a failure. So you basically just take the complement of whatever the success is. So if you look at the formula, you'll have the P that's the success, and this right here is the probability of the failure. And then what you have is your number of trials here for n, and then this is all the number of successes you want. So if you have 10 trials and you want 5 successes, you'd have 5n for k each here and here, and this would be n minus k. So let's go ahead and do an example. So this would be an example of a binomial probability because you're taking a multiple choice quiz that has 5 questions and you have 4 answer choices for each question. And it says, what's the probability you'll get exactly 3 answers correct by guessing? So the reason why it's considered binomial is either you're going to get it correct or you're going to get it wrong. So there's only 2 outcomes that you can have. Alright, so what we have is we have 5 trials here because there's 5 questions that we're either going to get right or get wrong. So we would have for n right here 5 questions, and we want to randomly get, now order doesn't matter, that's why it's a combination. We want to get 3 answers correct, where we don't care about the order of those 3 answers, we just want 3. So our number of successes is going to be 3 because that's what we want correct. The probability of getting it correct, well remember there's 4 answer choices, so the probability of a success is you have a 1 out of 4 chance, because remember there was 4 answer choices, and you want it correct 3 times. There's a 3 out of 4 chance, because remember the 1 minus P is the failure, and this is going to be twice, because remember there's 5 trials, and that means if you're getting it correct 3 times, then you would have to get it incorrect twice. Notice what these add up to. They always add up to the total number of trials that you have. So I just wanted to point that out. So then all you have to do is you can just type this into your calculator, and you'll end up getting 5c3, which is 10, and then you get 1/4 cubed times 3/4 squared, which would be 9/16. And so multiplying that out, you end up getting a 0.0879. So you have about an 9% chance of actually getting 3 correct by guessing. So the next thing we're going to be doing is making a binomial distribution histogram from our binomial probabilities. So here's the steps. So actually before I give you the steps, just so you know, a histogram is a bar graph. So you're basically looking at, you want to make a bar graph from your binomial probabilities. So you're going to be making a graph that looks something like that. So the first step is to make a table for k successes with their probabilities. And that table will look something like this, where k represents the number of successes and the p of k represents the probability of k successes. So what you're going to do is you're going to start off with getting no successes, 1 success, 2 successes, all the way up to the number of trials that you have. So if there's 10 questions or if there's 10 drawings, up to the number of trials. And the second and last step is to actually graph your results. So when you make your histogram, what you're going to have on the x-axis is the number of successes. And so you're going to go ahead and scale that, starting with getting no successes, getting 1 success, getting 2 successes, 3 successes, and so on. And then you are going to have the probability on the y-axis. And your probability is going to be anywhere between 0 and 1. So you'll be basically making your bar graph extending to some value up to 1. So what we're going to do for this second example is draw a histogram of the binomial distribution for the multiple choice quiz, that problem that we just encountered. So we're going to start off by making our table. So remember, k represents a success, and a success in this example was the number of correct questions. So we're going to start, if you remember, it was a 5-question quiz. We're going to start off by calculating if you get none right, so 0 successes, 1, 2, 3, 4, and getting all questions correct by randomly guessing. So now we need to calculate those, and we already did getting 3 correct. So if you remember, there were 5 total questions. We wanted to randomly choose 3. And the probability of getting a success was 1 out of 4. We wanted it 3 times. The probability of getting a failure is 3/4, and we wanted it twice to get a total of 5. And so we ended up calculating before that this was 0.0879. So we're going to go ahead and calculate it for 0 successes, 1 success, and so on. So this would be 5 questions, getting none right, so choose 0. Probability of getting it right is 1/4. We want it no times. And 3/4, we want it all 5 times. So plugging that into your calculator, you get 0.0237. To get 1 success, you would have 5C1. So you want 1 correct. Don't care about the order. You want it correct 1 time. That means incorrect would be 4 times. So when you go ahead and calculate that, it would be 0.396. Then you do the same. So this would be 5C2 times 1/4 squared times 3/4. And if we get it right twice, that means we have to get it wrong. We have to get 3 wrong. So this would end up being 0.264. Now I'm not going to write out the rest. Actually, I will. I'm just not going to take the time to write it on the screen. And then what I have is a binomial distribution for all possibilities. These are all of my possibilities right here. So if I were to add them all up, they should add up to 1. So I'm going to make that note here, because if these are all the possible outcomes, they should always add up to 100% or 1. So on the x-axis, I'm going to put on our k's, which is our number of correct questions. And on our y-axis, this is going to have to, I'm going to have to determine my scale from my probabilities. Because remember, the y-axis is the probability of that event happening. So looks like I'm going to go by 0.1s. And I did that because the largest I really have to go to is about 0.4, which is right there. So then I'm just going to draw my histogram or my bar graph. So at 0, I get about 0.237, so I would go up 0.25 is halfway, so it would be something about right here. And again, this is just an estimate, so that's the first one. The second one, getting 1 success or 1 question right, is really close to 0.4, so I'm going to get as close to it as I can. And I would get this for the second bar graph, or the binomial distribution. So then I graphed getting 2 successes, 3 successes or 3 questions correct, 4 successes, and last but not least, which is really close to 0, 5 successes or getting all 5 questions correct by randomly guessing. So this is called the binomial distribution. All of these bar graphs, if you were to add them all together, would add up to the 1 because it represents all of the possibilities you could have. So in this next question, I want you to tell me what the probability is that you get at least 2. So at least means 2 or more. So if you look back at the diagram or the table that we did here, 2 or more would be all of these guys right here. That's at least 2. So I'm going to add all those together. So when I add all those together, I get about 0.367 if I don't round. And that would be the probability of getting 2 or more correct. Another way you could have done this, so at least 2 is the same thing as if you did the complement of 1 minus the probability, and the opposite or the complement of at least 2 would be getting 0 or 1 correct. So I could go back to the table and I could do 1 minus these two guys. See how they're not included? Because remember, these all add up to 1. So that's another way you could do it. And if you notice, if I take the complement and subtract it from 1, then you'll notice that I'll get the same thing as well. So it's just two ways of doing the same. You're going to see Pascal's triangle. And one of the things that's significant about the triangle is that if you add the two numbers above, it's the number below. So like 4 and 6 add to 10. 15 and 20 add to 35. 4 and 1 add to 5, and so on. So basically what we have is we have a whole bunch of rows. So this right here would be row 0. This right here is row number 1. This right here is row number 2. Basically what you can do, this is row 3, is if you look at the number right here, this tells you the row it is. So you see how row 3 has a 3 right next to the 1? And then row 2 as a row 2. So this right here would be actually row 10. And if you want to put all the rows on there, that's fine. So you can actually use some probability combinations to calculate the rows of Pascal's triangle. So right here, this is row 8. So I'll put row 8. And I'm going to show you with the calculator using combinations how you can generate that. So what I've done is I've done 8C0. Notice how I get the 1. That's this guy right here. Then I do 8C1. I get the 8. That's the next term. 8C2 is 28. Next term. 8C3 is that. 8C4, 8C5, 8C6, 8C7, and last but not least, 8C8. So basically I can get any row of Pascal's triangle by using combinations. So if I wanted row 4, what I would do is 4C0, 4C1, 4C2, all the way to 4C4, which would be this term right here. 4C0, choose 0 is always the ones here. So that would be 2C0. This would be 3C0. That would be 5C0 because it's row 5. So you can get any row that you wanted. So if you wanted row 25, you do 25C0 all the way to 25C25. So this brings us to the binomial theorem, how we can expand a binomial to some power without having to do FOIL that many times. So these right here, the NC0, NC1, NC2, all the way to NCN, that all comes from Pascal's triangle. So those are going to be all the coefficients. So for example, if this was like a 3, then that would be 3C0, 3C1, 3C2, and so on. The other thing that you're going to notice is the exponents decrease by 1 each time till you get to 0. And then on the y's, they start increasing by 1 until they get to whatever this power is. So I'm going to go ahead and give you an example. So what you're going to do is you do not want to do this. You don't want to do 2x minus 1 and FOIL it out 4 times. That would be a pain. So I'm showing you a shortcut way. So what you're going to do is look at row 4 of Pascal's triangle. So row 4, the coefficients are 1, 4, 6, 4, 1. So you're going to write out 1, 4, 6, 4, 1. So what we've just done is we've just gotten all of our coefficients right here. Alright? So the next thing we're going to do is we're going to figure out the two things we're expanding. This is the x, and this is the y in the formula. So you're expanding a 2x and a negative 1. That would be your x and your y, basically. So the two things, you're going to copy them down next to each of them. So 2x, that should be a negative 1. And last but not least, the 2x and a negative 1. So what you're going to do is you're going to put pluses in between all of these terms. Okay, and then you're ready to put your powers. So the x term, the first term, this term right here, starts off at whatever you're raising it to. So since it's to the fourth power, I'm going to start the 2x to the 4, then it's going to decrease by 1 each time until it gets to 0. The y starts at 0 and then increases. So the y happens to be a negative 1, so it's going to start at 0, 1, 2, 3, and end at whatever the power is, at n. So n is 4. So now we're going to simplify. Anything to the 0 cancels out. It's a 1. So that's out of there. So now, here's what you're going to do. You're going to raise 2 to the 4th and x to the 4th and multiply it by 1. So 2 to the 4th ends up being 16, and then we're going to multiply that by 1, so we just get 16x to the 4th. Alright, now you're going to do the numbers first. So you're going to multiply exponents first, so you get 2 cubed, which is 8, times a 4, which ends up being 32, and then we're going to multiply 32 by the negative 1, so we end up getting negative 32, and then I have this x cubed. Alright, going on to the next one. Do powers first. So 2 squared is 4. And then negative 1 squared is 1. So I get 4 times 1 times this 6. So I end up getting a positive 24, and then now I can do the x's. So I get x squared. Here I end up getting a 2 to the 1st times a negative 1 cubed. Well, negative 1 cubed is negative 1 times that 2 is negative 2, and then times that 4, which is negative 8. And then I get x to the 1st. And last but not least, a negative 1 to the 4th times a 1 is a positive 1, so I get plus 1. So here's your final answer expanded. So if you were to do FOIL for this, you would end up getting this if you did it correctly. This is just a shortcut way of doing it. Okay, so here's one last example. I'm actually not going to do this one with you guys. I want you to try it on your own, and I want to see if you can get it. I'll be checking it tomorrow, and we'll go over it tomorrow in class. Alright, that's it. I have a great evening.